So I'm skipping section 1.2. I go to section 1.3, and section 1.3 continues to assume this toy example street vendor, but we still change a few things in the story. We assume now that before we assume that you are the street vendor, now we assume that the street vendor is somebody else than you. You are a researcher observing the street vendor, trying to find out, describe, predict what he does. So now this is a descriptive perspective. Before, when you were the street vendor, it was natural that we think what is the best decision, so it was normative perspective. But now it is descriptive, empirical. You just try to describe what you see of the street vendor. We're going to assume throughout this section that expected value holds. So you know that that street vendor is maximizing expected value. We're going to assume that this is an as-if model. You may remember from consumer theory that you assume that consumers maximize utility. But if you ask a consumer, what is your utility? They never heard of it. It is as if they are behaving on the basis of all kind of emotions, instinct, I don't know what. And this utility maximizing model just happens to describe nicely what they do. But they may not be doing this consciously in their mind. This expected value model may be the same. So we are assuming that the street vendor is choosing subjective probabilities P1, P2, P3, using those in his maximization, but it is as if he may not be aware of it. If you ask him, what are your subjective probabilities? He may say, well, I don't know what you're talking about. Anyway, still, we want to find out what his subjective probabilities are. So remember, these probabilities, they are not objective, written in a book or something. They are what the street vendor determined, maybe in a as-if sense, to make his decisions. So what are they? That's what we want to find out now. And it's not so easy. We had to do some sort of mind reading or heart reading to find out what they are. So it may not be so easy. Usually, if I ask this question to a non-economic audience, then at this stage they will say, well, just go to street vendor, ask what are the probabilities. But we do the economic game, the as-if model. We assume the street vendor doesn't even know. The street vendor just making decisions. So we're going to we're going to observe the decisions. We're going to do what the economists like so much, the revealed preference game. We're going to observe decisions from the decision maker, and we're going to derive from those what the probabilities are, what his attitude is. We're going to reveal a preference approach, let me call that the elicitation method, to prepare first an exercise. Assume that we observe that the street vendor rather receives €300 if no rain than €300 if all rain. And I ask you, you can derive from that P1 greater equal P3. I give you a minute to think about it, work on it, stop the video, work on it until you see it, and then come back. Okay, so now I assume you worked on it and come back, then I show you the solution. We have here this preference. That means the expected value of this triple is at least as much as of that triple. That means the expected value of this triple is P1 times 300 plus 0, 0. The expected value of that triple is 0, 0 plus P3 times 300. So we get that inequality means P1 greater equal P3. So there we are. Another exercise of this kind. If here, remember, X denoted ice cream, Y denoted hot dogs. If the street vendor rather take ice cream than hot dogs, that means that P1 must be strictly bigger than P3. I will just quickly say how it works. You remember ice cream and hot dogs, they both give the same €100 if some rain, so that doesn't matter for the inequalities. Both have a good and a bad outcome, 400 minus 400. But with ice cream, the good outcome is under no rain. With hot dogs, it's under all rain. And this inequality must imply on the expected value that P1, the probability of no rain, must be bigger than the probability of all rain. And if you substitute expected value, you easily see it. So this also follows. The algebra that you are seeing here and the algebra that we did so far is quite trivial. And maybe if you like to do mathematics, you think, what am I doing here? It's all trivial mathematics. But we don't do these things for mathematical purposes, we do these things for conceptual purposes. I told you in the beginning of this course that all the concepts, I want to operationalize them quickly, give you a feeling of the empirical content of these concepts. That's what I'm doing now. With subjective probabilities, immediately I'm connecting with empirical reality. And I think if you do these exercises, it's not mathematically difficult, but you get a better feeling, understanding of what subjective probabilities are. So it's conceptual. That's why I think you should, please, I hope that you will continue doing these exercises. You get a better feeling of the concept if you learn it this way. So that's what we do here. Also, you may observe that in a way, what we are doing here is a reversal to things we did before. Before, when we assumed that you were the street vendor, at some stage we were assuming that you determine subjective probabilities. Then when we know them, we can derive from that what your decisions are. Here, in a way, we are doing the opposite. We assume that we don't know the subjective probabilities, but we can observe the choices. And from the choices, we derive information about the probabilities. Like here, from the observed preference, we observe an inequality information about the probabilities. We do a bit of mind reading here. We learn about the subjective degrees of belief of the street vendor, even in an as if sense, but so be it. Well, we are more choosy, more demanding than what we did so far. We would like to find out exactly what P1, P2, P3 are. So far we found inequalities, but that doesn't give very much information yet. We want to find out exactly what they are. Then we assume that we are in an experimental heaven. Let me explain what I mean. You can, for every triple x1, x3, y1, y3, you can find out the preference between them. Even if this is the most hypothetical merchandise that you can imagine, this million, 5 million, 20 million or so, always you can find out every preference between every triple that you want. And exactly, no error. That's one assumption. Another assumption is that for any merchandise, any triple, you can find a certainty equivalent alpha, that is, the amount, if you can choose either, well, the merchandise, the street vendor then, if the street vendor can choose either to have this triple or alpha for sure, the street vendor is indifferent. So this getting the sure amount of that is equally good. That's the certainty equivalent, the sure amount equally good. Some notation, more or less implicitly going on here, is that getting alpha for sure, I just denoted alpha. That means you get alpha is no rain, alpha if some rain, alpha if all rain. So formally speaking, this is a notation that I am using, but it's quite self-evident. All right, so a question now is, how can we find out what P1, P2, P3 are? And I ask you now to pause the video for a while and then try to think by yourself. Imagine you are in the experiment heaven, the street vendor is there. How can you find out what the probabilities are? And I give you a minute to think. And when you're done, you organize your thought as much as you want, then open up the video again and start listening. Okay, I assume now that you have been thought about as much as you like, that you have maybe some first ideas. One thing we have already seen is if you observe preferences between triples, you get inequalities that give information about probabilities. That's already quite nice, but maybe inequalities are a bit difficult. You get upper lower bounds of probabilities if you have many of them. It's nice for this purpose we have now. It's nice to observe indifferences like here. They give equalities, and they much more quickly give you exact information about what those subjective probabilities are. So therefore, it's good to observe indifferences. Then if you think a little bit, first you think there are three unknowns. Then if you have three indifferents, you have three equalities of three unknowns, you can solve it, usually, unless you're unlucky. Here, in fact, the probability must add to one. There are only two unknowns. So if you just take two more or less arbitrary indifferences, you can already usually uniquely find what the probabilities are. That's in principle how we can solve this. Still, I want you to think a bit more about it. I want you to think what would be particularly easy. Can you think of a very easy, direct, simple kind of indifferences to elicit certainty equivalence maybe, such that you very easily get the subjective probabilities? So I'll give you another minute to think about it. So stop the video, think what's the easiest thing you can think of quickly, and then when you're done thinking, come back. Okay, so I assume you're done thinking, you're back again, but then let me show you what is the easiest way that I can think of. The easiest way is if you take, for instance here, you take merchandise giving €1 if no rain, €0 otherwise. you find the certainty equivalent of, so the sure amount of euros alpha that the street vendor is indifferent between receiving that or receiving this merchandise. Now, if you did that, then very easily you get the probability, because if you do some algebra, these two must have the same expected value. Expected value of the firm with probability 1, you get alpha, so that's alpha. And for the second, with probability P1, you get 1, otherwise you get 0, so that is P1. So from this, we get alpha is P1. That means you just get the certainty equivalent of that merchandise, and that is your subjective probability P1. You cannot imagine it could be easier than that. You can do the same thing with P2, with P3. In fact, if you have P2, then P3 is 1 minus P2 and P1. So anyway, that is the way you can get to know these subjective probabilities. And that is in itself already a big thing to do, because it's a bit like mind reading. If you can find the subjective probabilities of people, at first maybe you think the subjective probability is the subjective degree of belief in the mind of a person. To some extent, he thinks there may be no rain tomorrow. How likely it is quite vague number between 0 and 1. So if people tell you there's an easy way to find out what it is, an easy way to do mind reading, maybe you think that would be impossible, it would be magic. Here you have seen that it is quite easy to do. This was, I think, well, maybe that you can measure utility from choices, that has been known for some centuries. That's not so very surprising. That you can find degrees of belief of people from observing preferences, that you can read the minds of people. Conceptually, that was a big step. It was the Italian Bruno de Finetti in the 1930s, early 1930s. He was the person mostly really to understand this. That was a big step forward. And it's now it's used in many fields. If you measure degrees of belief of people, it's important for many purposes. If you are in marketing, to what degree do consumers believe that the product is safe? If you're a politician, what do people believe? What are their ideas? In many fields, people study this. In insurance, what do people think is the risk of getting some accident? All these things. Many people work all life long on belief measurement. It's a big field. Now I'm going to go to measure, predict, or maybe one more thing I want to tell about measuring belief. This is especially interesting if you measure beliefs of experts. And in weather forecasts, people do it a lot. For instance, maybe you don't only want to know, farmers don't only want to know if it's likely that it will rain tomorrow, but maybe if the probability that it will rain tomorrow is 60%, then you should not do something. But if it's 70%, then it's getting worthwhile. Risk can be quite subtle and refined. Therefore, weather forecasters are trained all life long in being very good in giving probabilities. What's the probability of rain tomorrow? One thing they do, so they are using techniques, well, more advanced versions of what I showed you a moment ago. One thing they, for instance, do is calibration exercises. They may ask a weather forecaster a year long to make predictions about rain. Then they look whenever all the days where he said the probability of rain is 80%. They look at it, they see in those days, in reality, only 70% of the cases there was rain. Then they go to the weather forecaster and they say, you are too optimistic about your certainty. If you think that you know something 80% sure, in reality it's less, it's probably only 70% sure. We think you should become more modest and less extreme in your estimations. You have overconfidence. But that's one of the many examples. These weather forecasts, all their life, they are trained with these things. They are very good, very sophisticated. And there are big economic interests in getting this done. So belief measurement is a big field. You saw only the very trivial thing of it, but much can be done. Now let me continue on measure predict exercises. An exercise to prepare. Assume that you observe the street vendor is indifferent between 100 if no rain and nothing otherwise, or 50 for sure. So 50 is the certainty equivalent of this triple. You also observe 100 if some rain is equally good as 25 for sure. So then this is the certainty equivalent. You observe those two indifferences. Now, first I ask you, can you calculate what the subjective probabilities, the degrees of belief of the street vendor are from these two observations? Well, this is like what we did before. Now I ask a bit more. Can you tell what the certainty equivalent is of this triple of getting 100 if there is all rain? And one more question. Imagine here a triple and here a triple, 100 under some rain and 100 under all rain. What is the preference of the street vendor between these two? So this is something for you to work on. So now stop the recording and work on it for a while until you found the solutions. When you're done, come back. Okay, I assume you come back now. I show the solution. So the first indifference means this triple and 50 have the same expected value. The expected value of this thing is P1 times 100 plus 0. Well, that must be 50 because the expected value of this thing is just 1 times 50, that's 50. And now we see P1 times 100 is 50. So P1 must be 0.5. And we look at the second indifference. The expected value of this thing is P2 times 100. The expected value of that thing is, of course, 25. So P2 times 100 is 25. So that means P2 must be 0.25. P3 we can also calculate. It's 1 minus, the other is also 0.25. So now we know all the subjective probabilities, and then we can calculate from the certainty equivalent of this triple. The expected value of this is 0.25 times 100 is 25, but the expected value is a certainty equivalent, because that's, she can get one for sure, has the same expected value of the lottery, so unexpected value are indifferent. Indeed, in expected value maximization, the certainty equivalent of a lottery is always the expected value of the lot. Anyway, this is what we get here. And the preference between those two triples, well, it turns out to be that they are indifferent because the expected value of this is 0.25, probability 0.25 times 100 is 25. Here also P3 is 0.25 times 100, also 25. They have the same expected value, they are indifferent. So you find this indifference. So you see a sort of how you can, if you know expected value maximum, if you have a model, you can make predictions by observing some preferences. You can predict other preferences. That's what's happening here. We observe these two things, and then we can predict other things happening in the future. This is the measures predict pattern of expected value maximization. Actually, this is the pattern of every empirical science. Always you assume some theory, then you do some observations to get some information, some calibrations, and on the basis of the observation and the theory, you can make predictions. This is the whole business of all empirical sciences. Here you see how it works in decision theory and for expected value maximization. Now I'm going to the next section, section 1.4 and 1.5. That will continue on this toy example, but it will again be a change of story. It will be normative again, but that will come in the next recording.